Alright guys, so we are going to finish up our notes. We're going to start with, it's page 10, simple gas laws. So for this, you must know what these variables represent. Pressure is for P, V is for volume, N is moles, and T is temperature in Kelvin. Remember, calculations with temperature must be made in Kelvin. And you guys should know this already. Now, we're going to review these gas laws really quickly. Since you guys have done the reading, you've done all your practice problems, this should be pretty quick. So, Charles' law relates temperature and volume. If the temperature increases, then the volume must increase as well. Opposite's true. Volume decreases, the temperature must also decrease. We call this a direct relationship. Now, these two graphs right here, this is what a direct relationship looks like. So these two pictures, when we want to talk about a direct relationship, what would the graph look like? It's going to be a straight diagonal line moving on up. As one increases, the other increases as well. Now, according to Charles' law, heating a gas will make it expand. Gas molecules move faster when heat is added, and they hit the container walls with more force. So if you're thinking of these little particles moving around, as they move faster, they're going to hit it with more force, and they're going to be hitting the walls of the container more often. This is going to cause the volume of a flexible container to increase. So it's going to be pushing the walls of the balloon outward. Now, cooling is going to do the opposite. There's going to be less collisions, they're less forceful, so the volume will go down or decrease. So, equation for Charles' law, we have volume over temperature equals volume 2 over temperature 2, and you guys have done this a bunch of times already. Now, when you're doing these problems, always remember temperature 1 and temperature 2 have to have the same units. It has to be in Kelvin. Volume 1 and volume 2 also must have to be the same units. So you can have those volume in any units you want as long as they're the same. Temperatures always has to be in Kelvin. Alright, so now you guys have 3 example problems. You guys, if you want to pause the video right now, work through those example problems, and then start it up and I can go over the answers. So we have here, for the first example, we should have a temperature 2 of 208.6 Kelvin. Alright, next problem. We have a container with an initial volume of 17 liters and a temperature of 313, and the pressure of 1 atmosphere. If the temperature changes, then pressure stays the same. So since the pressure doesn't change, we don't even have to use that in the problem. All right, so go ahead and work out this. And you should get 19 liters. All right, finally, we have 12 moles of a gas, a volume of 25 liters, and a temperature of 300 Kelvin. Number of moles stays the same. What's the new volume if we increase 25 degrees? So we're starting at 300 and we're going up to 325. Okay, so you have to convert the degrees Celsius into Kelvin. Answer for this is 49.83 liters. So go ahead and check your work and see if you did this correctly. All right, next one is Boyle's law, and Boyle relates pressure and volume. So if the pressure increases, volume decreases, pressure decreases, volume will increase. This is an inverse relationship. All right, and the graph for inverse relationship looks like this. Now, don't necessarily worry about this. This is just showing you if you plot the inverse volume, so 1 over volume, it's going to give you a straight line, and that's why it's an inverse relationship. So this is just explaining why Boyle's law is inverse. All right, equation is P1 times V1 equals P2 times V2. All right, here's your couple of example problems. Go ahead and work through these. Pause the video, and then you guys can keep going. So first example problem, you should have 12 liters for your volume 2. Next example problem, remember we don't have to worry about the number of moles because it stays the same. Our answer is 2.9 atmospheres. Third example problem. For this, we have to make sure our pressure is in the exact same unit. So we have to convert toward atmospheres. Then we can plug it in the equation. So the answer for this, we get 4.8 atmospheres for our pressure 2. So go ahead and check your work and see how you did. All right, other equations, we have Gay-Lussac's law, which is pressure and temperature, and then Avogadro's law, which you did not have in your reading, and that's volume and number of moles. So as you increase the number of moles, then the volume will increase as well. That's another direct relationship, and those are going to have that same graph with the diagonal line pointing up. All right, some new stuff. We have Dalton's gas law, and Dalton basically, his law says that you can add up all the individual pressures of a gases, like if a mixture of gas, you can add up all the individual pressures to get the total pressure. So when we use Dalton's gas law, we're talking about partial pressure, and partial pressure is just the pressure of a single gas in a mixture. To find the total pressure, you just have to add up all the partial pressures to give the total. And then we have our combined gas law. That's exactly what we've been doing before. P1 V1 over T1 equals P2 V2 over T2. So we've got that same law right there, and that is the one that you're going to use all the time. All right, so a couple example problems with the combined gas law. You guys work these out, and pause the video and resume as soon as you guys are ready. So we've got a weather balloon, volume of 410 liters, cooled from 27 to negative 27. Pressure is reduced from 110 to 25. What is the volume? So we'll always remember, convert degrees Celsius to Kelvin. So here we have all our knowns and our unknown volume 2. Our answer then should be 1,479.28 liters. All right, next we have the ideal gas law. PV equals nRT, N equals moles, R equals your gas constant. You've done some of these probably. We have R. If we're using atmospheres and liters, we can use 0.0821 like you've been doing. Now, if you want to keep your units of pressure in kilopascals, you can use another constant, which is 8.314, and that's if you're ever going to use kilopascals. All right, so go ahead and work through this problem, and then check your answer in a minute. So first up, we're converting grams to moles. So we're going to divide by 44, and then we're also converting milliliters to liters. Plug it in the equation, you get 0.533 atmospheres for your pressure. All right, finally, the last topic is volume conversions. Equal volumes of gases contain equal volumes of molecules at the same temperature and pressure. So basically, we learned before that 1 mole of a gas will have a pressure of 22.4. Now, if you are 22.4 liters, as long as the pressure and temperature remain the same, if it's a little bit different, it doesn't matter what the gas is, it's always going to have the same volume. So what you can do is use your balance equation, and you can get a volume ratio instead of a mole ratio to figure out how much gas you need to react. So you can basically substitute your moles for liters, and then you'll have the same equation. So we have, in the first one, we have nitrogen plus hydrogen yields ammonia. And if we look here, we have 1 mole of N2 plus 3 moles of H2 yields 2 moles of NH3. So if we're starting with 3 liters of H2, that means that we need only 1 liter of N2 to fully react. Now, if we want to make 2 liters of NH3, we can just say that we are combining 1 liter of N2 and 3 liters of H2. So we can use those coefficients as liters of gas. All right. So now all you have to do is, if you have a conversion, let me move that around a little bit. So if we want to know how many liters of hydrogen are required to react with 22 liters of N2, we just have to multiply by the coefficient. So we're going to do just like we did with moles, pretend it's like a mole-to-mole problem. Instead, now we're using liters. So we start with 22 liters of N2, divide it by 1 liter of N2, because that's the coefficient of N2, multiply by the coefficient of H2, which is 3, and we will end up with 66 liters of H2. All right, quick review. We've got a direct relationship, okay? So volume versus temperature or moles. Those are both our direct relationship. Now this one has to be volume versus pressure, and that's our inverse relationship. So this one should be our inverse, and this would be pressure. All right, finally we have another one, and it's pressure versus temperature. And here's our direct relationship, and it's Gay-Lussac's law. All right, guys, now you should be able to finish all of your vocab sheet for today. Have a good one. I'll see you tomorrow.